Hello students, myself Amrita Roy. Today we are going to study about the chapter Economic Aspects of Utilizing Electrical Energy. Economic Aspects of Utilizing Electric Energy. The function of a power station is basically to deliver power at the lowest possible cost per kilowatt hour. This cost is made up of fixed charges consisting of interest on the capital, taxes, insurance, depreciation and salary of managerial staff, the operating expenses such as cost of fuels, water, oil, labor, repairs and maintenance. So the cost of power generation can be minimized by operation through fewer men having uniform design, selecting station as to reduce cost of fuel, labor, and sometimes reducing the amount of investment in the plant and choosing the equipment that is available for operation during the largest possible percentage of time in a year. Next is costing of electrical energy. The total cost of power can be divided into three parts. What are they? They are basically the fixed cost, semi-fixed cost, and the running or operating cost. The fixed cost basically includes the annual charges of the central organization management, salary of the employees, and the interest on the land cost. Semi-fixed cost is independent of the energy, that is kilowatt hour generated, but it depends upon the maximum demand, and higher the maximum demand, the greater will become the semi-fixed cost. And semi-fixed cost includes the interest and depreciation on the capital cost on the land, the buildings and the cost of the equipments needed for generation, transmission and distribution of electricity. The capital investment of the plant is huge and usually loaned. Semi-fixed charges also include the salaries of management and other clerical staff, since these depend upon the size and cost of installation, which again depends on the maximum demand. And sometimes due to wear and tear, the depreciation occurs, and such depreciation costs are also included in the fixed and semi-fixed charges. Next is the running or operating cost. As the name implies, the running charges will depend mainly upon the energy in kilowatt hour generated by the plant. Running cost includes the cost of fuel, the cost of maintenance and repairs, salaries of the operating staff and other cost. Cost of fuel includes varies with the type of plant. It is lower in case of thermal coal-based plant, and in case of nuclear power plant, it is high. However, for hydroelectric plants, this cost is nil. Cost of maintenance and repairs. As a plant ages, wear and tear occur. That is, as the plant ages more, as the years passes, the machines, the generators and other turbines that are present in a power plant, they get damaged and maintenance is required for that purpose. And so for that a different amount is required for the repairment and inspection and maintenance of those elements. So for that we need a cost of maintenance and repair. The equipments required for that may include the lubricating oil, which has also a different cost. Next is the salaries of the operating staff. So the higher the size, that is the capacity, the more will be the number of operating personnel required. That is, the higher the size of the plant, more number of people or men will be required for inspection of the plant, for supervision of the plant, for proper taking care of the plant. So for that we need to keep more amount of people or personnel for the proper inspection of the plant, and for that, as the number of heads of people increases, the salaries of the managerial staff also will keep on increasing. That is, it means it is directly proportional. And other cost includes these are always not applicable for all plants, but this consists of charges for feed water, and that is included for thermal power station, and water treatment cost, which is required for hydroelectric power station and thermal power station, and enrichment of fuel cost, which is required in nuclear power station. Next is the formulation of electrical tariffs. So the total annual cost is as we have discussed earlier, is basically equal to the fixed charge plus the semi-fixed cost plus the running cost. So we know that fixed cost is constant, semi-fixed cost is proportional to maximum demand and independent of energy, that is kilowatt hour generated by the plant, and running cost is proportional to the energy generated. So the total annual cost is equals to, we can represent it as capital A plus B. We have the unit for B as kilowatt plus C. We have the unit for C as kilowatt hour, that is C is in basically representing the part coefficient of the energy generated and B the maximum demand. So we have put the unit of B as kilowatt and C as kilowatt hour. So A is equals to annual fixed cost, B a constant which when divided by maximum demand gives annual semi-fixed cost, and C a constant which when multiplied by the annual kilowatt hour output gives annual running cost. However, sometimes it is more convenient to include fixed cost together with semi-fixed cost. This simplifies the tariff scheme. So the total annual cost can be represented in this case as A plus B, where A is a constant which when multiplied with maximum demand gives us the annual cost of the first part, and B is the constant which when multiplied by the energy output gives the annual cost of the second part. Now, what are the various types of tariffs present in a plant? So the following factors are taken into account when we try to decide the electricity tariff, that is the type of load, maximum demand, the time at which the load is required, the power factor of the load, and the amount of energy used. So the type of load basically can be divided or classified into three types: domestic, commercial, and industrial. The industrial consumers use more energy for a longer time than domestic consumers, and hence the tariff for the industrial consumers is more compared to the domestic consumers. The tariff of the electric energy varies according to their requirement. Similarly, for maximum demand, the cost of electrical energy supplied by a generating station depends on the installed capacity of the plant and kilowatt hour generated, that is the energy generated by the plant. The time at which the load is required, the time at which the maximum load required is also essential for the electricity tariff, that is when there will be peak demand or peak requirement from the consumer or industrial side of the consumers. So the station must be ready to supply the maximum energy generated by the plant. So if the maximum demand coincides with the maximum demand of the consumer, then the additional plant is required. The power factor of the load. The power factor basically plays a major role in the plant economics. The lower power factor increases the load current, because a poor power factor will draw more load current, and similarly if power factor of the plant is improved, it will draw less current, so it will cause less amount of losses in the system. But if the power factor is very poor, it will cause the system to go through more losses. So thus regulation becomes much poor. So for improving power factor, the power factor correction equipment is installed at the generating station. Next is the amount of energy used. The cost of electrical energy is reduced by using a large amount of energy for longer periods. Next is importance and need of energy conservation. Energy conservation is basically the effort made to reduce the consumption of energy by using less of an energy service. This can be achieved either by using energy more efficiently. Energy conservation is also a part of the concept of eco-sufficiency. So energy conservation measures is in building reduce the need for energy services and can result in increased environmental quality, national security, personal financial security, and higher savings. It is at the top of the sustainable energy hierarchy. It also lowers energy cost by preventing future resource depletion. So energy can be conserved by reducing the wastage and losses, improving efficiency through technological upgrades, and improved operation and maintenance. On the global energy level, it can be reduced by the stabilization of population growth. Energy can also be transformed from one form to other, such as heat to motive power in cars, or kinetic energy of water flow to electricity in hydroelectric power plants. However, machines are required to transform energy from one form to other. The wear and friction of the components of these machines while running cause losses of very high amounts of energy and very high related cost. So it is possible to minimize these losses by adopting green engineering practices to improve the life cycle of the components. What are the measures of energy conservation in electric drives? We can do energy conservation in electric drives by the use of efficient semiconductor converters, use of efficient motors, variable speed drives, and also sometimes using a motor of the right rating, use of single to three-phase semiconductor converters in rural applications, regular and preventive maintenance of motor transformers and coupled equipments, energy efficient operation of drives. Next is measures of energy conservation in electric traction. There is ample scope in reducing auxiliary power energy consumption using half load and coasting. So energy consumption towards auxiliaries can be controlled by sensing half load condition by traction power or temperature of power equipments and switching on and off auxiliaries accordingly. Next is measures of energy conservation in electric heating. So we can use doors and windows with heat insulation, that is double glazing and insulated doors. Treat cold bridges, that is door and window frames, load bearing structures such as pillars or beams, and provide screens, that is shutters, to reduce losses through openings. Adapt sunscreen devices to avoid solar radiation when cooling is required. Measures of energy conservation in refrigeration. So it can be reduced by using gas-powered refrigeration, using free equipment to minimize electrical demand charges, cooling, using refrigerated water loads in series if possible, and convert firewater or other tanks to thermal storage. So it can allow chiller shutdown to cold weather. Next is the measures of energy conservation in air conditioning. So we can improve that by right size of AC required for our space, programmable temperature settings, that is by using sensors, energy saving settings and Wi-Fi enabled setting, energy star setting, high EER and SEER settings. Measures of energy conservation in illumination. It can be controlled by using lighting controls, replacing magnetic ballast with electronic ballast, and optimum use of natural sunlight, and replacing mercury light with the metal halide or high pressure sodium lights. Thank you.